So welcome to this video. In this video we are going to take what we know about piecewise functions and apply that to an application. We've already talked about piecewise functions, how you evaluate using a graph, how you evaluate using the algebra, and now we are going to take that a step further and we're going to build a piecewise function based on some information given to us. So if you see here, we've got a sales company and they're advertising a job. And the way they're structuring this job is you can make an annual salary of $10,000 plus commission. All right, so their commission rate is 8% of all of the sales up to 100,000. So basically what this means is this particular person who works at this job is going to make $10,000 no matter what. All right, and how they're going to increase their salary is they're going to sell these items, whatever the items may be, and whatever the value of those sales are, they receive 8% of that. So 100,000 sounds like a lot if you were just selling, something like pizzas, right? But if you're selling, say, cars, right, or maybe furniture, some high dollar items, you could pretty easily get to 100,000. So, who knows what we're actually talking about here, but for this particular situation, they'll make $10,000 plus 8% up to this $100,000 in sales. All right. Now, if they go over that, okay, if they have more sales than that, if they exceed the 100,000, their commission rate bumps up to 12%. All right, so that's sort of an incentive, right? That's the company's incentive to make you want to sell more, right? Because you get that higher percentage of commission when you get over that 100,000. So first of all, let's start our piecewise function, and we need to use the s, right? Because they said the function is s of x. So that means the function is named s, and we need to use the x variable in our function setup. Okay, and we're going to have two scenarios. The first scenario is pretty easy to set up, I think. It's $10,000 plus 8%. Make sure you change that to the decimal of your sales, which are x. Okay, and this is going to be applicable when you have sales between 0 and 100,000. Okay, and there's the first piece. I think that's pretty straightforward. Now for the second piece, what a lot of students want to do is they want to say 10,000 plus 0.12 of x. All right, but this is actually incorrect. All right, so if that's what you were thinking, you got caught in the trap. Okay, so you have to really think about what's going on and understanding how commission works. So the way this works is everyone receives 8% on that first 100,000. Okay, once you go past that 100,000, your commission rate bumps up to 12%, but that's only applicable to the sales that exceed the 100,000. So if you have sales of 150,000, you're going to receive 8% commission on that first 100,000, and then you're going to receive 12% commission on that 50,000, because that's the amount that's over the 100,000. All right, so when you try to set up the piecewise function like I showed here, you're basically saying they're going to get 12% on all of their sales, which is not going to happen. Okay, so we have to get that guy out of there. All right, so what is going to happen is they're going to pay you the $10,000. Okay, they're going to pay you the 8% on that first 100,000 of sales. And then they're going to pay you 12% of the sales that are over the 100,000. So that will be x minus 100,000. Okay, and if we clean this up right here, that gives us 18,000. So we can say 18,000 plus 0.12 of x minus 100,000. And this will be for sales that are greater than 100,000. Okay, and there's your piecewise function. So let's graph the function. All right, so the first graph, the first piece, it's pretty easy to graph. You have a slope of 0.08 and you have a y-intercept of 10,000. It's a linear function. So if we mark 10,000, all right, and then we just draw a line, okay, with this 0.08 slope, which is not really that steep. All right, and that's going to take us to an x value of 100,000. So just mark that down on your x-axis. Then for the second part of the graph, all right, we actually need to clean this up a little bit. So I'm going to come down here and distribute the 0.12. All right, and then combine your like terms. So we would have 0.12x plus 6,000. 6,000 is the y-intercept. 0.12 is the slope. So if you imagine 6,000 on your graph, all right, I'm just going to make the first part dotted so we can kind of visualize what's happening here. You have a little bit higher slope. 0.12 is bigger than 0.08. Okay, and so just imagine that linear function coming through like that. And the only part that you want to actually include on your graph is going to be the part at 100,000. Okay, and so right there at that x value of 100,000 is where the slope of the line changes just a bit. So now I can go back and I can erase this part here because that's not actually part of the final graph. Okay. All right, so now let's talk about part B. Okay, so they're saying our sales are 120,000. So that is obviously in that second piece, right? Because 120,000 is greater than 100,000. So we want to plug in to that second piece. So that's 18,000 plus 0.12 of 120,000 minus 100,000, which is just 20,000 there. So if you want to just put 20,000, that's fine. And then punch that into your calculator and you're going to get $20,400. Okay. And that would be your your salary if you had $120,000 in sales. All right, now for part C, they're flipping things around on us. They're actually giving us the salary. Okay, so maybe a person is trying to decide should they apply for this job and they know they need to make at least $40,000 a year to pay for their mortgage or their rent or whatever bills that they have. So they're trying to figure out how much would I have to sell each year? What is this amount of sales that would get me to this salary? So think about what just happened when we did part B. Okay, part B, we got to this salary here, and that was using $120,000 in sales. So since 40,000 is bigger than 20,400, I know that I need to go into the second part of the piecewise function. Okay, and what you do is you just set that equation or that piece, that second piece, equal to 40,000. And you solve for x. Okay, I'm running a little low on space here. All right, so you want to distribute the 0.12 and you want to subtract the 18,000 from both sides. So when I subtract the 18,000 from both sides, I'm going to get 22,000 and I'll distribute the 0.12. Which we actually did some of the simplifying up above there, so you could use that same simplifying if you wanted to. And then I need to add the 12,000 to both sides, which will give me 34,000. and then I need to divide both sides by 0.12, and then punch that to the calculator, and you're going to get $283,333.33. All right, and you can just round to 2 decimal places since we are talking about money. So that is the amount of sales you would need to have this $40,000 income. Once again, if you're selling cars, maybe like Teslas or a high-end car, that's actually not that many cars that you have to sell. So it might be very achievable to have that much in sales. Okay. So anyway, what you have to do with piecewise functions is just really think about the situation and think about real life numbers and how those would be applicable to the situation, and just very patiently and slowly create that function. Anyway, ask questions when you have them, and I'll see you online.